So hi, my name is Franziska. I'm working for the online supermarket All You Need Fresh, and I am very happy to share my favorite project with you today. It's about the fact that food is personal. Imagine you're in a normal supermarket. You see endless shelves packed with different items, usually between 4 and 40,000 unique products. But if I stand in front of these shelves, I would pick just a few of them. And if you stand in front of this shelf, you would pick a different item set. And so do most of us. That's why we from All You Need Fresh had the mission to build an individual supermarket for everyone. So the front door of our supermarket is the web shop. Once you enter the web shop, you'll find an individual shelf for every user. Convenient to fill the basket, to find products you are interested in, but additional novel and inspirational products. This journey started 1.5 years ago. So we are able to share some learnings today. The first one is, how is it possible how we provide personal food to our customers? The second one is that we prove food is truly personal. So let's start with the first point. Usually, if you want to provide a list of ranked items, recommender systems are the tool of choice. There are various application areas for recommender systems. The most popular ones are exemplified here with Netflix and Amazon. There are two major tasks a recommender system can perform. It's on the one hand side a prediction task, on the other hand side it's a ranking task. Predictions are, for example, made if Netflix estimates a prediction for you for an unseen movie that you will rate it with 3 or 4 stars. A ranking is made when Amazon says, customer who bought this item also bought this one. So they provide a set of 5 to 10 different items which are ranked to you. This is a small list of items. Additionally, recommender systems can provide a large list of items. Sorry. And we have a quite new domain we can apply recommender systems to. We already heard in the talk before that they try to do it. I know we have a lot of different companies here dealing with food, so e-grocery is a new hot topic in this area. And that's why we will focus on ranking large lists of items for e-grocery. But to do so, we need to understand where is the difference between classical e-commerce and e-grocery, since recommender systems have been out there for years. So why do we have to have a special focus on e-grocery now? There are 3 major differences. First one, we know user preferences. We have the opportunity that customers buy a lot of items at the same time, usually more than 10 distinct items. While in classic e-commerce, they buy 1 computer, 1 book, or 1 type of diving goggles. So once a user has his first order, we know a lot about his preferences and we are able to find similar users on a quite valid base. Second advantage is that due to the high product baskets, we are able to identify co-purchases between items. Much easier than Amazon, for example, could do. So someone who buys wine often buys grapes and cheese, and other combinations which are very popular for different products allow us to find similar items with high reliability. And the third and most convenient one for us is that users buy products frequently. So if you buy a milk, it's probably finished by 4 days. After 4 days, it's very likely that you buy a new milk, which is likely the same one you had before, because you always drink this kind of milk. While if you have bought the diving goggles, it's very unlikely that you go to Amazon again trying to buy the same diving goggles. Also, they try to make us do so. So we have repeated purchases, which allow us to have quick win recommendations. Very easy, cheap ones. Everyone is very likely to buy again. These three advantages sum up to a major one, which is we have simply more data than the others. This data can be utilized in collaborative filtering, which is usually the method of choice in this situation. There are two types of collaborative filtering. Classically, we have the user-based collaborative filtering, which relies on customers who have and show the same purchase behavior. For example, customers who bought just the same type of products or share 80% of them. I buy milk, I buy coffee, I buy cream, and you buy the same, so we are very similar. And others who buy different stuff are less similar to me. On the other hand, we have the item similarity, saying these items are frequently bought together, and that's why they are similar. What we try to do now is to link these by the transactions a user does. So before we had to choose, is it better to go with user similarity and an item-based collaborative filtering, or to go with item-based collaborative filtering? So either the one or the other. Now when we link it, we are able to use the whole information network. Since this is an advanced talk, we'll have a deep dive in the algorithm, starting, like every recommender system in collaborative filtering, with the user item matrix. It shows which user buys which item. So for example, here we have user 1 who have purchased item 5. We have user 5 who purchased items 6 and 7. Based on this, we are able to calculate the similarities between different users, saying user 1 bought a lot of products user 2 did, so they have high similarity. But just a few of the ones, for example, user 5 did. And on the other hand, we have item similarity, which is a bit misleading from the wording, because it's not this milk is similar to this milk, but it is about this product is often purchased with this product. Because if a user once buys milk and this is the best milk for him, there's no point in showing him just substitutes of milk. He won't buy it. He wants something to go with the milk, like muesli or cereals or something else. So here, item similarity bases on co-purchases. This information is then brought together in a heterogeneous network. What is meant by heterogeneous network? It describes that the network has two types of nodes. One are users, the others are items. So we have, like in the very easy example in the beginning, on the one hand, the users and their similarity, and on the other hand, the items and their similarity. These are linked by the purchases user 1 did, for example here item 5, and the other users did. To have a large list of items, we then have to have a look at every user and item combination because we want to rank the whole shop for our customers. So we have a target user and a candidate item we pick, and we construct a subnetwork for them, saying these users are similar to this one, and these items are similar to this item. So we can extract the following information out of it. We have, for example, here user 5 having a similarity of 0.5, and we have item 1 with a similarity to 6 and 7, which come up. And then we put this information in a scatter plot. For example, user 5 would be this one having a similarity of 0.8, and the item similarity sums up to 0.7. And this is then enriched by a regression through the origin, which means we will see how big, how relevant the item is to me if it is often bought together with items of similar users. It will have a high slope with a strong significance, and if it has no very explicit learnings from them, it will just be randomly distributed, and we won't have a good indication by this. So we perform an F-test, and the p-value of this F-test gives us the indication of the rank of the products. The more significant it is, the higher the product is ranked for this user. So in the end, we have an output of a ranked list over every item for our user. And this is done for every user and every item. Okay. You got it? We went through it. Now you know the basic functionalities and how we can incorporate user and item similarity at the same time. Now we'll have a look how we can prove with this that food is personal. Since we can't really know beforehand, you may be asked, how do we know? Since we are an e-commerce company, it's quite easy. We can test it. So what we did is first performed an offline test of the algorithm. Afterwards, an online test, because only if the customer really interacts with our recommendation, we see how valuable they are for him. Since offline tests are very well documented, we'll focus now on the online test, which is the juicy bit of it. So this is our shop. You see here the elements where you can click on categories and see a ranked list of products. On average, each category has around 2,000 items included. So if a customer comes to the shop, he sees maybe the first 12 items. This stressed the relevance a good ranking has for him, because if these 12 items are not items he prefers, it's very likely that he thinks we don't offer the products he likes, and he won't convert. So the personalization applies right here. Whenever someone clicks on these categories, he will get a personalized ranking. At least he provided history for us, so made his first order. But important to note is that search is another recommendation task not handled with this kind of personalization. So what we focused on the online test is how people react on this personalized rankings in the categories. So what did Group A get? They had a semi-personalized ranking, which is the status quo. They have items which they frequently bought in history ranked first, and then they had a cluster approach for the rest of items where we don't know preferences for. Group B got the output of the algorithm I just showed, and so they get a personalized ranking over the products. this is quite abstract. So I bring an example of a colleague of us, Cassia, which is vegan and was very kind to give you an impression by indicating for ranking A and B which products she would buy, which is a tick, and which products she wouldn't buy or even think it's disgusting. So since she is vegan, it's quite easy to assume what she likes, or easier to assume what she didn't like, because meat is obviously not the right product to recommend to her. So on the left-hand side, you see her ranking at the same day, at the same time, for the status quo. Where you see, sorry, where you where you see that she's a regular buyer, because there are quite a lot of products ranked first from her previous purchases. And then you see where the normal ranking hands over, where it's just of a large group of people ranked for her preferences, which is not very successful because we have a lot of meat here and products she just would not buy, but additionally she thinks it's not appealing to her, so maybe she is not in the mood to shop anymore when she sees a lot of meat. So in the other ranking, we had the case that it's not that concentrated on the top, but it's spread all over the page. There everywhere are products which are interesting to her. So she is appealed to just keep looking at the products and see what we have more for her. And still we have a few products which she would not like, which is, for example, ecological or biological meat, chicken here, which might be bought with vegan products as well, which is the case since it is in the ranking, but it is far less. So we have on the one hand side 9 versus 17, and on the other one we have 14 versus 3 products she won't like. This is the increase the level of relevance for her. So after, in the first case, she stops after the first 2 rows because she thinks she won't find any good products anymore. And on the other hand, it scrolls down far more down the page. For new categories where she haven't bought a lot of before, like this one, she had just bought 3 items, or maybe they are even just from the cluster ranking provided to her. It looks like the assortment is not bad, but not attractive to her. On the personalized case, we see that she now has a quite good product assortment, having fair trade chocolate, vegan Haribo, and all this stuff she might like. So we have 4 to 7 in this case, and 15 to 0 on the other one. Of course, this is not an A/B test. I just tried to give you an impression on how this looks for a customer. And if we assume it looks this or the same for every customer, we can imagine how the A/B test affects the people. So what was the outcome? For the customer, we had a significant decrease in shopping time, as many people go to e-grocery because they try to achieve more convenience. Shopping time is a critical element of customer perceived value. So in the first group, in the status quo, they took around 67 seconds in median between 2 add to basket clicks, while in the personalized group, they just needed 3.3 seconds less. Of course, there are a lot of outliers, people just leaving the computer or start to chat with friends or whatever. So we have on the box plot here, you see how these outliers might affect the evaluation. That's why we took the median as a robust measure of the average. And we have here a closer look to the distribution where you can see, okay, it's not a single effect on some users which might change the picture. It is a shift of the distribution, and especially as the higher part of more than 100 seconds, we have at the 75% quantile, we have a strong reduction in time. The second effect is that users increased functionality usage. You know that they had the chance to either search for a product or go through the ranking and navigate. So in case A, where they get the ranking as before, just 31% of their products were added via the ranking. All the others were done by search. While for B, they obviously were attracted by the portfolio of products we offered, and they increased usage a lot, relative by 44%. But what is benefiting the customer should hopefully benefit the company as well. So let's have a look at the numbers. The significance was an increase of revenue because more orders were made per customer, and per order they bought more items. So we had a double effect on the revenue. We had on one hand side, just with the same amount of users, we had more orders, and for every and each order of them, we had more items, in average, of course. So this sums up to an increase by 7%. Summing all together, we are able to provide personal food when we combine the rich information about users and items. Second, food is personal because people showed us that they liked what they see, that they want to use it, and that they find more products that they will buy, and they came more often to see what we have for them. That's a clear indication that the new version of our ranking, which was tested at the same time for a random distribution of people, was more valuable to them than the old one, which was just semi-personalized. Good. These 2 points you can take with you. I know there are a lot of e-grocers here as well, so I think that's the direction we should go. Next step would be to have a look at search and other possibilities to have a more personalized implementation for the user. Important to note is that e-grocery is different from other commerce. So you need to focus on the special requirements, but still I think we are able to provide good recommendations in every e-commerce field. So, like every other company in this field, we are hiring. So we are 10 people here today. If you see all you need on the tag, you can just go by and get some information or get it here. We are working with Google Cloud and try to bring a lot of these recommender systems and other cool stuff to our shop. So if you want to work with it, just drop by. Thank you, and questions are welcome. Yep. Mm-hmm. Yeah. That's a good point. So the question was, if we take into account historic purchases and like bring in new inspiring products as well, right? The good thing is we rank 4,000 items, and as you can see in the example, users just have usually preferences for the top 7 or something. So of course we need to include it anyway. And the advantage of this algorithm is that it stresses the behavior of the user we are looking at, but at the same time it's looking for the behavior of similar users. So it is not purely ranking his historic purchases first, which is this quick win recommendations and easy, but he could even go to his last purchase and say, I want to buy all. That's a functionality we have anyway. So in the ranking, we try to mix all of them, and the algorithm does it quite well without a lot of adjustments in there. So when I go, I'm a regular buyer. When I go to the page, I think if I have these 2 rows, they're around of 2 products out of 12 I already bought, and the others are just products fitting well to my preferences. Ah, okay. Yeah, yeah. So it's recalculated every day, and it has some parameters stressing seasonality and stuff. So it, for example, if my last purchase was last summer, I might have the same problem in winter that I would just get my summer basket. So since it is filled with the information of other users as well, it always changes. It's not like it changes every day completely, but there is a kind of exchangement in it. Please. Hmm. No, we went with purchases because it was hard to interpret if a user adds a product to his basket and removes it, is it still like, or is it maybe dislike because he got more information out of it or something? So we just went with the information we have, like he is well aware that this product fits his preferences, that's why he buys them. And we didn't went to the topic on how to interpret different click streams in when is it still a like and when is it a dislike? What does this interest means? Yeah. Hmm. So the question is that if in the basket of the user, if they are complementary goods or substitutes, right? We Okay, so we have both. For example, if someone likes a special brand, he often buys a lot of products from this brand, different types of Bionade, for example. And then this is incorporated, but it all depends on the user behavior. So there are substitutes in there, but there are also complements. It's just it's capturing both. And for me, as I see it, it's around 50-50 because I mean anyway we have to rank all products, and so it's a mixture. Yeah. So we solve it at the moment that this is a memory-based approach, so we just calculate it once a day and then the calculation is ready. Since there are not too many users buying twice a day, this is not even relevant for us. And then we just insert the ranking, and whenever the user logs in, he gets one time loaded the catalog and then it's rendered for him. So it's not, we tested it because we were afraid that the shop might crash. And Colin and me just took one night to file a lot of users to the shop, and it went fine. So it was no page load problem. So this is how we approach it. Please. Mm-hmm. Yeah, this is anyway for customers who log in and who purchased before. So how to provide this personalized feeling to new customers is what we are working on, but at the moment this is just for people saying we want to buy and we already bought. That's the status quo. Because it's always hard, I mean, that's the problem of recommender system, it's cold start, right? What to do with new people we know nothing about, and that's not captured by this one, but will be in future. Yes, because the shop deletes the ones which are not available at the moment. So they are not replaced yet, saying the product is not available, give the next best one from the same category or something. That's not done. It's just sorted in the end of the ranking. No. No. It's just based on the ranking, and so the users who buy them frequently and similar users get them a kind of preferred, but that's not a rule we set. That's what the algorithm does on its own. That's implicit. Because the other one who won't buy it anyway, or where it's unlikely, they are just sorted in the end where they normally don't scroll down to. So indirectly it's incorporated, but it's not that there is a rule. Yes? Mm-hmm. Yeah. So we had more than 20,000 in our A/B test, and so more than 20,000 orders. So I tested before because, for example, AOV or revenue sometimes is quite volatile. So we had before we had a test to see how this evolves with a random assignment of groups having no differences, to see when it's really significant, because it converges at some point and we wanted to know which one it is. So we tested it before. Significance is not always that easy that it's always true, so you need to be aware of how your measure works, and that's how we did it. Okay, there's one here. Mm-hmm. Mm-hmm. No, I think that's a kind of philosophy question. Last year, I and a colleague were on the recommender systems, and we had quite debates about how to include content. And my point of view is, if you have enough data, all the content is included because people bought milk, sugar, and coffee. And if not, there is no evidence. There is no point in me bringing up a rule which may be outdated. So this algorithm is not capturing any special content or rules someone defines. It's working on its own. Yeah, that's the point. We are thinking about it as well. It's just another functionality. It's a new task, right? This one was how to rank the products. If someone goes, it's like if you go to the shelf of drugs or fresh food, your fruits are first, then the one which are likely for you, and then and in the end there's the stuff you don't like, and you won't go there anyway because you find everything you want before. That's the ranking task we try to solve. And this is a new functionality which would need new design of algorithm for it, or maybe reuse this one, but still that's a point, but not for this task. Okay, you maybe? It's two. It's Christine here and me. And we are lucky because I'm in the business intelligence team, having colleagues helping me with the data and the ETL jobs and everything. So there is support from getting to the data, and the IT team helps to implement the information and get the process work. But about how to design it, how to evaluate it, it's us. Yeah. That's more strategic question. So I'm not offline. You mean in the offline market? Okay. I don't think that our board tries to get the offline session, since we are one of the e-grocers which are just online. That might be a question more for Rewe or Real. But for us, there is no point in bringing it to a physical supermarket. But there are studies about how personalization might work in offline markets as well. So, like for example, with electronic boards, having some ads or guide you through a specific route or something. So there are play arounds, but we are not focusing on this. Yeah. Okay, so thank you for your for being the audience. I hope it was fine. You can see me today here, so if you have any further questions, just come by.